Good afternoon, everyone, and welcome to today's SaferSim webinar. The SaferSim webinar series features researchers and students sharing detailed information about their projects. These projects use simulation to address transportation safety issues. Thank you for joining us today. Before we get started, I would like to point out the chat box in your Adobe Connect window. That chat box is in the bottom right-hand corner of the window. Feel free to use that chat box for any questions or comments. There will also be time at the end of the presentation for those questions and any further discussion. So now I'm pleased to welcome our presenter from the University of Massachusetts Amherst, Sara Bakhtiari. And she will be presenting her work on the dynamic signage for visually impaired pedestrian safety at roundabout crossings. So welcome, Sara.
Hi, thank you, Jacob. I'm Sarah, and I'm very pleased to present this project that me and my lab mates, we were working on this. The project is about dynamic signage for visually impaired pedestrian safety at roundabout crossings. So, as we know, pedestrians are some of the most vulnerable road users, especially at intersections and roundabouts. So, while the continuous flow of roundabouts may be beneficial for traffic operations, it can come at the cost of pedestrian safety. From the driver's perspective, it's sometimes hard to get some information like detecting the pedestrian from the roundabout or crosswalks at the roundabouts. And from the pedestrians' perspective, especially visually impaired pedestrians, it's sometimes hard to detect some auditory cues to cross the roundabouts or intersections. Pass or cross the roundabouts. Because the continuous flow of roundabouts kind of reduce the auditory cues, so it's kind of hard for them to detect those. In addition, traffic approaching from many directions, it can be confusing and dangerous for visually impaired pedestrians. So in this regard, for the benefit of the driver, roundabouts are signalized. So it can improve the safety for pedestrians and also drivers. But and how? It can alert drivers for the presence of the pedestrian and increase the ability of the pedestrians for crossing the roundabouts. But it also can reduce the efficiency and operations of the roundabouts. And how? Because it can cause visually clutter with increasing the signs at the roundabouts, and it can put some cognitive loads on drivers. Because as we know, when drivers are navigating the roundabout, there are some cognitive loads on them because they have to keep themselves on the lane, so their focus is mostly on the road instead of getting some information from the signs. And if we go through the literature review, we will see that mostly the researchers for improving the safety is from the pedestrian's perspective. But in our research, we tried to do this from the perspective of the driver. We tried to improve the awareness and yielding behavior of the driver. So we are trying to be close in the middle, improve the safety, and keep the efficiency and operation of the roundabout. So Uh, in this regard, we come up with this proposed pedestrian activated warning sign. So as you can see, this sign is not static, is dynamic. Uh, it has a blank mode and it has a flashing mode as well. So when it's if you look at this sign, you can see a circle in the middle of the sign that it shows the roundabout, and those symbolic crosswalks are presenting the crosswalks. So then it's in the blank mode. It's saying that it's less possible that there is a uh, crosswalk. There is a pedestrian at the crosswalk. However, when it's flashing and when it's activated, it means that there absolutely there is a pedestrian at the crosswalk. So if we look at this sign, we can understand that it's has it is informing uh, drivers about exactly which crosswalk is the latent hazard is. So the sign is intended to improve situational awareness and reduce the cognitive load of the driver with providing this useful information. And it can provide a better traffic flow as well. So this is our sign that we are proposing in this research. To test the application of this sign, we design an experiment, and so we used our driving simulator. As you know, we have upgraded the simulator, and this driving simulator is a fixed base simulator with a full body 2013 model Ford Fusion sedan, which is surrounded by five main projection screens and one rear projectors. It has six screens in total, and participants they have uh, approximately 330 degrees of field of view. So with this simulator, we are able to collect the data from the vehicle, like velocity, acceleration, and their lane keeping. Another equipment is eye tracker. So with this eye tracker, we are able to capture their eye glances, and so we can have a better understanding from the behavior of the driver. So this for this experiment, we developed 8 scenarios with roundabouts. And so because it's uh, our design for this study is a within subject experiment, so all of the participants they drove one scenario with the first drive. So they had in total 2 drives. The first drive was with the conventional sign, and the second drive was with the new sign. And to have a better understanding that how we develop with this with these scenarios, these 8 scenarios, we had 4 virtual worlds. So because we wanted to eliminate the effect of orders, so we developed these 4 boards. Uh, so it's like right turn with pedestrian, right turn without pedestrian, and left turn with pedestrian, left turn without pedestrian. And then for these 4 roads, we added signs. So 4 with the conventional sign and 4 with the new sign. And each driver drove one of these 4 roads, first with the conventional sign and then with the new sign. And so for experimental design, I have to say that so we had 3 steps: simulator, eye tracker, and questionnaire. So we collect some data from questionnaires, eye tracker, and simulator. And I have to say that the dependent variable was is actually eye glances and also vehicle measures. So because we wanted to see how we can improve their behavior, we use these measures. And also I talked about the independent variables in the previous slide, that is the turn type, pedestrian persons or not person, and sign type. So the experimental procedure was like other experimentals. Procedures is first drivers, they came to our lab, and then we talk about the experiment a little bit, and then talk about our simulator, and then they provided with the IRB informed consent, and then a demographic questionnaire, which was about their age, their gender, and yes. So then we asked them if they are familiar with the simulator or they have been in our lab or not. If they were, so there was no need to have a demo, but if they weren't, so we asked them to have a demo. For 2 reasons: because we wanted them to be familiar with our simulator first, and then we wanted to make sure that they are not gonna get motion sickness. After calibrating their eye tracker, they started their demo, and then after we made sure that they are comfortable and they can start the experiment, we first ran the experiment with the first drive. The first drive was one of those 4 volts with the conventional sign, and second drive was again the same one with the experimental sign. After they finished their study, their experimental drives, they were provided with some questionnaires. The first questionnaire, so first we asked them about their understanding about the sign. So, and the second question, after they were done with the first questionnaire, we explained about the sign, how does it work, and then we asked about their feedback and how hard it is for them to understand the sign. So around 24 drivers took part in our study, and fortunately they didn't face any motion sickness. So we finished our experiment with just 24 participants, and at the end we started to analyze the data. So to have a better understanding, first we went through the simulator data and we analyzed their velocity. So to analyze the velocity, we categorized the data in 4 categories. So conventional with pedestrian, conventional without pedestrian, experimental sign with pedestrian, and without pedestrian. As it is illustrated in the plots, and you can see the black lines are the averages. So to compare them, we put them in the one just plot, and as it is obvious from this plot, you can see that there is no significant difference between the conventional and new sign. But the only difference was when the pedestrian was at the roundabout. And I have to say that when we were designing the experiment, we put it at the exit leg of the approach the roundabout because we because that that position is kind of tricky for drivers, and it's less likely for them to expect a hazard. So because of that, we put that there. I forgot to mention. For completeness, we track the acceleration as they approach the roundabout. So as you know, the simulator is collecting data from the whole scenario, and because we just wanted to analyze data in 2 points, we put two sensors. The first sensor was 100 meters far from the roundabout, and the second one was at the crosswalk. So as we expected, we didn't get any significant result, but it's a little obvious that their acceleration was less with the proposed sign in the first point and in the second. So we got some good results from their eye glances, and as I mentioned before, we used the eye tracker to capture their eye glances. So for the conventional sign in the left picture, so you can see that we have two signs. The first sign is the roundabout sign, and the second sign is the pedestrian sign. So after calculating the proportion of glances toward these two signs, we had these good results that roundabout warning sign just had 48% and pedestrian yield sign had 19%. So after analyzing the conventional signs, we went through the videos of the new sign, and then we saw that the experimental sign percentage was about 52%. And it was so if you compare these numbers, you can see that we were successful. We could, with this new sign, improve their glances. Actually, they glanced more at the new sign. So we provided more information just with one sign instead of two signs. We distracted them less with just one sign instead of two signs. And we provided more information because our new sign is talking about the presence of the pedestrian that is exactly we are mentioning which crosswalk is the hazard. And so we improved their situational awareness, and so we kind of got a good results. Another thing about the eye tracker results, we realized that the pedestrian was detected by almost all of the participants because it wasn't a latent hazard, it was obvious. So multiple signs may actually be less effective than a single sign. To have a better understanding, we went through the questionnaire analysis, and so we went through their answers. We wanted to see what took their attention and what they talk about, and after analyzing their responses, we came with some good results that first in the first, as I explained before, the first questionnaire that was about, actually the first post questionnaire, we asked if what is their understanding about this sign. So almost most of them they understood the meaning of the sign, and it was interesting for us. And after we explained the sign, we gave them the second questionnaire, and they mentioned that it was very easy for them to understand, and there is nothing hard. And they said that they got more familiar after the study, after we explained it well for them. So it was good to see that result. So to wrap it up, uh, we didn't find much with the speed, but we improved the glances. For the velocity, uh, then there was just the only difference was happened when we had pedestrian, not signs. And but for the from the data which we collected from the eye tracker, we uh, realized that the glance rate improved a lot, uh, and so we can claim that with this new sign, we kind of reduce the visual clutter. We can claim that we reduce the cognitive burden on the driver, because driver has to focus more on the road, and so this signage is really helpful. And another thing that we can say is that just we used one sign instead of two, and we provided more information for them. So I think it's a good result. And from the questionnaire, we realized that most of them mentioned that almost around 18 participants, they said that the basic concept of the experimental signage was easy to understand, and they understood it well. So to have a better understanding about the driver's comprehension of the proposed sign, there is an online survey questionnaire which is going on to have more data. So for future work, we think that it's better to investigate this sign in different weather conditions. Because, for example, in foggy weather or snowy weather, it's hard to see the static sign, and maybe we can see that, and we can prove that uh, our new signage, because it's not static and it's dynamic, it can uh, capture their glances more, and then it's more useful, and we can improve the safety better without reducing the efficiency and operation of the roundabout. And when we were developing the scenario, we didn't obscure the pedestrian, so maybe it's better to obscure the pedestrian, then we have one more measure. So we can say if the participants, if the drivers were able to, for example, detect the pedestrian, it shows that it uh, works well. So in future research, we can obscure the pedestrian to have one more measure to uh, actually have a better understanding of the behavior of the pedestrian. Because we were doing this experiment in UMass, most of the participants were from UMass and they were young drivers. So we couldn't see how we couldn't actually see the behavior of elderly drivers. As you know, elderly drivers they suffer from eliminate they suffer from um, uh, they actually their situational awareness is less than younger drivers. So uh, it's kind of it can be interesting to have this study with elderly drivers, see how we can improve their awareness. And last but not the least, we can work on the signage actually design, not the overall, but we can improve the uh, actually the performance of the sign, to work on the frequency, increase the frequency, and uh, also the frequency and the brightness. So the results of this study right now is under review for TRB, and I'm ready to answer any question which is related to this study.
Thank you, Sarah. We'll open the chat up for anyone that has any questions.
Yes.
I had a question. I know in your results, the eye tracking results, you said the conventional setup, the first sign was viewed at a 48% rate, and was it the pedestrian sign was glanced at 19% of the time. Where was that second sign located in the roundabout? I know you had the first ones were located right at the entrance.
We wanted so when we were designing the scenarios, so we had a picture from the roundabout at UMass. So the first sign was a bit further from the roundabout, which was warning drivers about the roundabout, and the second one was exactly at the crosswalk. Actually, in roundabouts at UMass, it's like this because we tried. So did I answer well, or I need to? Yeah.
Yeah, that makes sense. Yep. I just wanted to make sure that I knew where that second sign was located at, because that seems, if it's only getting glanced at 19% of the time, that doesn't seem like even the current location, that like it's not that effective.
Yes, because it was up. So when they glance at the first sign, they mostly ignore the second sign because they were navigating the roundabout, I think, and so they were focusing more on the lane keeping, and instead of uh, getting information from the roundabout, like or signage. Yes. Yes.
Yep, that makes sense. Thank you.
More questions?
So we have another question that came in. You mentioned obscuring the pedestrian and weather conditions. The vehicles didn't show any other vehicle traffic in the intersection. Do you think drivers might see a difference between the two signs if there were other vehicles that draw the driver's attention as well?
There was a slight traffic, but I think it wasn't a lot, but I think we had 2 cars or 3 cars, maybe. Yeah, they were passing from the roundabouts. Yeah. So I have to add one more thing, that so the traffic was very slight, but maybe in heavy traffic this sign would work better because there are the workload, cognitive load on driver is more when the traffic is heavy. But um, yes, in our scenarios, the traffic was not heavy. Is it clear? No?
Yep. So Dawn was the individual that asked that
Yeah.
question, and she said, yep, there's more objects to pay attention to with the more traffic, so that would make sense. It looks like there is some more typing, so we'll see if we get another question. Uh, Another addition on that comment with other vehicles, the pedestrian might be missed more often than a benefit
Yeah.
to the sign. I'm saying.
I didn't get you. So this is another question.
Okay.
Okay, so guys, yeah.
I think that is all the questions right now. I'll have you go back to your last slide just so we can get your
Yeah.
email address up there one last time. So if there are any further questions, feel free to reach out to Sarah directly. And I'd like to thank everyone that was able to attend today. We will get this webinar posted online on our website and YouTube by the end of the week, and we'll also send that out to all the registrants. So thank you everyone for attending, and keep an eye out for our future registration information. Thank you.
Thank you.
Enjoy the
Thank
rest
you,
of your day.
everyone that listened to my presentation. Thank you.